In the heat of World War II, the skies over Europe were a deadly ballet of aerial combat. On one side, the formidable German Messerschmitt Bf-109. On the other, the iconic British Supermarine Spitfire. For a time, these two legendary fighters were almost perfectly matched. Almost, but one seemingly insignificant flaw in the Spitfire was costing pilots their lives. When a Spitfire pilot pushed their plane into a steep dive, the engine would often cut out. This was due to a problem with fuel flow under negative G-forces. For a few terrifying seconds, the pilot would be a sitting duck, powerless as the Bf-109s swooped in for the kill. The best British engineers were stumped. They tried everything, but a solution remained elusive. The stakes couldn't have been higher. The fate of the Royal Air Force, and perhaps the entire war, hung in the balance. Little did they know, the answer wasn't going to come from a complex redesign or a multi-million-pound project. It was going to come from a brilliant woman with a simple, elegant idea, an idea that would cost less than $1. Her name was Beatrice Tilly Schilling, and she was an engineer at the Royal Aircraft Establishment. While her male colleagues were focused on massive, complex solutions, Tilly took a different approach. She understood that the problem wasn't the engine itself, but how fuel was delivered to it during those critical high-G maneuvers. The carburetor float would get pushed up, flooding the engine and causing it to stall. It was a simple problem of physics, and Tilly believed it required a simple solution. She wasn't a pilot or a high-ranking officer. She was a hands-on engineer who loved getting her hands dirty and solving puzzles. Day after day, she analyzed the carburetor's design, running tests and simulations. She saw what others had missed. The issue was all about controlling the flow. After countless hours in the workshop, Tilly came up with a brilliantly simple device. It was a small, thimble-shaped metal piece with a precisely calculated hole in the center. Officially, it was called the RAE restrictor. But pilots would soon give it a much more affectionate and slightly cheeky nickname: Miss Schilling's orifice. This tiny piece of metal, which cost about the equivalent of 50 cents to produce, was designed to be fitted into the Spitfire's carburetor. Its job was to limit the maximum fuel flow, preventing the engine from flooding during a negative G dive. It didn't completely solve the problem, but it bought the pilots precious seconds enough time to regain control and fight back. It was an incredibly elegant and cost-effective fix. Instead of overhauling the entire fuel system, Tilly's invention was a small, easy-to-install modification that could be rolled out quickly. The effect was immediate and dramatic. Tilly Schilling and a small team flew from one RAF base to another, personally installing the restrictors in as many Spitfires as they could. Pilots who had once dreaded entering a dive now found they could push their aircraft to the limits without the engine sputtering and dying. The Spitfire, already a nimble and powerful fighter, was now even more deadly. It could now outdive and outmaneuver the Bf-109. That momentary hesitation, that split second of vulnerability that had plagued Spitfire pilots, was gone. German pilots who had grown accustomed to exploiting this weakness were suddenly caught off guard. A Spitfire that went into a dive was no longer an easy target. It was a predator about to pounce. This small 50-cent piece of metal had completely changed the dynamic of aerial combat over the English Channel. The impact of Tilly Schilling's invention cannot be overstated. It is estimated that her simple metal washer saved the lives of thousands of Allied pilots. By giving them the confidence to fly their machines to their absolute potential, she leveled the playing field and then tilted it in the Rave's favor. Pilots could now perform maneuvers that were previously impossible, giving them a crucial edge in dogfights where victory and defeat were decided in a heartbeat. Beatrice Schilling wasn't a frontline hero in the traditional sense, but her ingenuity and engineering prowess made her one of the most important figures in the Battle of Britain. Her story is a powerful reminder that sometimes the biggest problems have the smallest solutions, and that a single brilliant mind can change the course of history. Her legacy is etched into every Spitfire that flew, a testament to the woman who fixed a deadly flaw with a 50-cent piece of metal. In the last episode, we talked about a critical flaw in the legendary Spitfire fighter plane. Its Rolls-Royce Merlin engine would cut out during a steep dive, a problem that German pilots in their Messerschmitt Bf-109s ruthlessly exploited. British pilots were forced to perform a clumsy half-roll and pull maneuver just to keep their engines running, giving the enemy a golden opportunity to escape, or, even worse, get on their tail. The Royal Air Force was losing pilots at an alarming rate, and a solution was desperately needed. The problem was traced to the carburetor. In a dive, the negative G-force would cause the fuel to slosh away from the carburetor's float needle, starving the engine of fuel. Engineers at the Royal Aircraft Establishment at Farnborough were frantically trying to solve this puzzle. They tried redesigning the float chamber and adjusting the fuel pressure, but nothing seemed to work consistently. Every failed attempt meant more pilots were at risk. The pressure was immense. The Battle of Britain was raging, and every single Spitfire was crucial to the defense of the nation. It seemed like they were up against an unsolvable engineering nightmare. But then, an unsung hero stepped into the picture. Her name was Beatrice Tilly Schilling, a brilliant and determined engineer working at the Royal Aircraft Establishment. Tilly wasn't just any engineer. She was a trailblazer, a woman who had defied the conventions of her time to pursue her passion for mechanics and motors. She was an accomplished motorcycle racer in her spare time, known for her skill at tuning engines for maximum performance. She understood engines inside and out, not just from theoretical diagrams, but from hands-on, grease under the fingernails experience. While many of her male colleagues were stumped, Tilly approached the problem with a fresh perspective and a practical mindset. She knew that a complex, time-consuming redesign of the carburetor was out of the question. The RAF needed a fix, and they needed it yesterday. She understood the urgency and the lives that were on the line. She wasn't looking for a perfect, elegant solution. She was looking for something that worked, something simple, and something that could be implemented immediately across the entire fleet. So Tilly and her team went to work, and what she came up with was not some complex piece of machinery, but a stroke of simple genius. It was a small, thimble-shaped metal device with a hole in the middle. It was officially called the RAE restrictor, but pilots and mechanics gave it a much more affectionate and slightly cheeky nickname, Miss Schilling's orifice. This little piece of metal, which cost only about a shilling or 50 cents back then, was designed to be fitted into the carburetor's fuel intake. Its function was beautifully simple. It limited the maximum fuel flow to the engine, preventing the carburetor from flooding during that initial negative G lurch. It didn't completely solve the problem of fuel starvation, but it gave the pilot a crucial couple of seconds before the engine cut out. 2 seconds was all they needed. It was enough time to complete a dive, line up a shot, or evade an enemy attack without the engine sputtering to a stop. The device was so simple it could be installed by ground crews in a matter of minutes without needing to take the engine apart. In early 1941, Tilly Schilling herself led a small team that traveled from one RAF base to another, working tirelessly to fit the restrictors into every Spitfire and Hurricane they could get their hands on. Imagine the scene, this remarkable woman amidst the hustle and bustle of active airfields, personally overseeing the installation of her life-saving invention. The pilots were initially skeptical. Could this tiny piece of metal really solve a problem that had plagued them for months? But their doubts quickly vanished on their very next combat sorties. The impact of Miss Schilling's orifice cannot be overstated. This simple 50-cent fix, conceived by a brilliant female engineer, fundamentally changed air combat tactics over Europe. It leveled the playing field and then some, giving the Spitfire the edge it needed to dominate the skies. It's estimated that Tilly Schilling's invention saved the lives of thousands of Allied pilots. It allowed them to fight more aggressively and survive encounters that would have previously been fatal. Yet, for many years, her contribution remained largely unknown to the public, a footnote in the grand history of the war. But today, we remember Beatrice Tilly Schilling not just as an engineer, but as a hero. Her story is a powerful reminder that sometimes the most significant breakthroughs don't come from massive, expensive projects, but from a spark of ingenuity, a practical mind, and a simple, elegant solution. It's a testament to the fact that one person with a good idea can indeed change the world. Thanks for watching, and if you enjoyed this story, make sure to like, subscribe, and hit that notification bell for more incredible tales from history. See you next time. Have you ever heard the saying, "Good things come in small packages"? Well, in the darkest days of World War II, one of the smallest, most unassuming pieces of metal would go on to save thousands of lives and change the course of the air war over Europe. This is the incredible and often overlooked story of how a tiny metal washer, costing less than $1, helped the legendary Spitfire outfly its fiercest rival, the Messerschmitt Bf-109, and the genius behind this life-saving innovation, a brilliant woman engineer named Tilly Schilling. Now, let's set the scene. It's the Battle of Britain. The skies are a chaotic ballet of dogfights. The Royal Air Force is desperately trying to defend its home turf against the relentless Luftwaffe. The RAF's premier fighter is the Supermarine Spitfire, a beautiful and powerful aircraft. But it had a critical, and often fatal, flaw. Its Rolls-Royce Merlin engine was carbureted. When a Spitfire pilot would push the stick forward to dive, the negative G-force would cause the engine's carburetor to flood. This would lead to the engine sputtering, coughing, or even cutting out completely. Imagine you're in a life-or-death dogfight. You dive to escape an enemy on your tail, and your engine just gives up. For a few terrifying seconds, you're a sitting duck. The German Bf-109s, on the other hand, had fuel-injected engines, so they didn't have this problem at all. They could dive away with impunity, leaving the struggling Spitfire pilots vulnerable. This was a huge tactical disadvantage, and it was costing the RAF dearly in both planes and, more importantly, pilots. The engineers at Rolls-Royce and the Royal Aircraft Establishment were scrambling for a solution. They knew a full switch to fuel injection would take too long. They needed a fix, and they needed it now. This is where Beatrice Tilly Schilling enters the story. Tilly was an exceptional aeronautical engineer, one of the few women in her field at the time. She was known for her nonsense attitude and her incredible problem-solving skills. She rode a powerful Norton motorcycle and was famous for tuning it herself until it could top 100 miles per hour. She was exactly the kind of person you'd want tackling a problem like this. Tilly and her team at the Royal Aircraft Establishment in Farnborough got to work. They analyzed the problem from every angle. The issue was simple physics. During a dive, the fuel in the carburetor's float chamber would surge upwards, flooding the engine's intake and choking it. The long-term fix was a pressurized carburetor, but that was still months, if not years, away. They needed a quick, effective, and simple patch. After much experimentation, Tilly came up with a brilliantly simple solution. It was a small, thimble-shaped metal restrictor with a hole in the middle. Officially, it was called the RAE restrictor, but pilots soon gave it a more affectionate and slightly cheeky nickname, Miss Schilling's Orifice. This tiny piece of metal, which cost about 50 cents to produce, was designed to be fitted into the carburetor's fuel line. Its job was to limit the maximum fuel flow, preventing the chamber from flooding during a negative G maneuver. It wasn't a perfect solution, mind you. If a pilot dived for too long, the engine could still be starved of fuel. But it did solve the immediate problem of engine cutout during a quick dive or a sharp pushover. It gave Spitfire pilots those crucial few seconds they needed to stay in the fight. The implementation was rapid. Teams of engineers and mechanics, including Tilly herself, traveled from one RAF base to another, working around the clock to fit the restrictors into every Merlin engine they could get their hands on. The effect was immediate. Suddenly, Spitfire pilots could follow a Bf-109 into a dive without their engine quitting. The tactical playing field was leveled. Now, the Spitfire's superior turning ability could be fully exploited. Pilots no longer had to fear that crucial moment of vulnerability. This small 50-cent washer gave them the confidence to fly their aircraft to its absolute limits. The impact of Tilly Schilling's invention cannot be overstated. It directly addressed a critical weakness and gave British pilots a fighting chance when they needed it most. It saved countless aircraft from being shot down and, more importantly, saved the lives of thousands of brave pilots. It's a powerful reminder that sometimes the most profound solutions aren't the most complex or expensive. They come from clever thinking, a deep understanding of the problem, and a touch of genius. Tilly Schilling may not be as famous as the pilots she helped, but her small 50-cent washer played a giant role in winning the battle for the skies. Her story is a testament to the unsung heroes of the war. The engineers and innovators whose brilliance on the ground made victory in the air possible. The Spitfire was an incredible machine, a symbol of British defiance. But early in the war, it had a serious problem. When a Spitfire pilot tried to dive steeply, the engine would suddenly cut out. It was a terrifying moment, losing power just when you needed it most, especially with a German Messerschmitt Bf-109 on your tail. The problem was the carburetor. In a sharp dive, the negative G-force would cause the fuel to flood the engine, choking it. Pilots had to perform a half-roll and pull through, a maneuver that took precious seconds and made them a sitting duck. The Germans, with their fuel-injected engines, didn't have this problem. They could simply nose down and dive away, leaving the Spitfire pilots struggling to catch up. This small technical glitch was costing lives and giving the Luftwaffe a dangerous advantage in the skies over Britain. It was a puzzle that needed solving, and fast. The answer didn't come from a team of high-profile male engineers in a fancy lab. It came from a woman named Beatrice Tilly Schilling. Tilly was a brilliant engineer and motorcycle racer working at the Royal Aircraft Establishment. She wasn't your typical engineer of the era. She was known for her sharp mind, her no-nonsense attitude, and her love for speed. When she heard about the Spitfire's engine-cutting problem, she immediately set her mind to it. She understood the physics of what was happening. The G-forces were disrupting the fuel flow in the carburetor's float chamber, while others were proposing complex and expensive redesigns of the entire carburetor system. Tilly looked for a simpler, more elegant solution. She knew that a complete overhaul would take too long, and pilots were being lost every day. She needed a quick fix, something that could be implemented across the entire Royal Air Force fleet almost overnight. Her solution was astonishingly simple, yet utterly brilliant. It was a small, thimble-shaped metal restrictor with a hole in the middle, which looked a bit like a washer. Officially, it was called the RAE restrictor, but pilots affectionately nicknamed it Miss Schilling's orifice, or sometimes the Tilly orifice. This tiny piece of metal cost pennies to make, maybe 50 cents in today's money. It was designed to be fitted into the Spitfire's Merlin engine carburetor. Its job was to limit the maximum fuel flow during a negative G maneuver, preventing the engine from flooding. It didn't completely solve the problem, but it gave the pilot a crucial few seconds of full power before the engine sputtered. Those few seconds were often the difference between life and death. A pilot could now push the stick forward and dive directly after a Bf-109 without their engine instantly quitting. The impact was immediate and profound. Tilly and her team personally toured RAF fighter bases, installing the devices themselves. They worked tirelessly, often in cold, damp hangars, to make sure every Spitfire and Hurricane was fitted with her invention. The pilots couldn't believe it. This tiny 50-cent washer had solved a problem that had been plaguing them for months. Suddenly, the tables were turned. Spitfire pilots could now match the Bf-109s in a dive. They could stay on an enemy's tail, follow them through aggressive maneuvers, and break away with confidence. The psychological boost for the pilots was immense. They no longer had that nagging fear in the back of their minds about their engines failing at the worst possible moment. The playing field had been leveled thanks to Tilly Schilling's simple, ingenious fix. It's impossible to count exactly how many lives Miss Schilling's orifice saved, but it's safe to say it was in the thousands. By giving RAF pilots the ability to outmaneuver their opponents, this tiny piece of metal changed the dynamic of air combat during the Battle of Britain and beyond. It's a powerful reminder that sometimes the most significant breakthroughs don't come from massive, expensive projects, but from a single, clever idea. Beatrice Schilling, a woman in a field completely dominated by men, used her practical genius to create a solution that had an outsized impact on the war effort. Her story is one of ingenuity, determination, and the incredible power of a simple, elegant design. It's a testament to the fact that even the smallest part can make the biggest difference. Have you ever heard the saying, "For want of a nail, the kingdom was lost"? Well, today's story is the exact opposite. It's about how a tiny piece of metal, costing less than $1, helped win one of the most critical air battles in history and saved thousands of lives. This is the incredible, unsung story of the Spitfire's secret weapon and the brilliant woman who invented it. We're in the thick of World War II. The skies over Europe are a battlefield. On one side, you have the Royal Air Force's iconic Spitfire, a symbol of British defiance. On the other, the Luftwaffe's formidable Messerschmitt Bf-109. These two planes were the heavyweights of the era, locked in a deadly dance. The Spitfire was agile and a superb dogfighter, but it had a critical, often fatal, flaw. Pilots discovered this flaw in the worst possible way during a high-speed dive. When a Spitfire pilot pushed the stick forward to chase a Bf-109 downwards, something terrifying would happen. The engine would cough, sputter, and cut out completely. A sudden gut-wrenching negative G-force would cause the carburetor's float to lift, flooding the engine with too much fuel and starving it of air. For a few terrifying seconds, the pilot was a sitting duck, powerless, as the German plane either escaped or, worse, turned the tables. The only fix was to roll the plane upside down before diving a clumsy and time-consuming maneuver that often cost pilots their lives. The problem was so severe that RF Command was desperate for a solution. Top engineers at Rolls-Royce, the makers of the legendary Merlin engine that powered the Spitfire, were stumped. They tried everything they could think of, but nothing worked. The issue seemed unsolvable. The Germans, on the other hand, had their Bf-109s equipped with fuel-injected engines, which didn't have this problem at all. This gave them a massive tactical advantage. They could simply nose down and dive away, leaving the sputtering Spitfires behind. Enter our hero, Beatrice "Tilly" Schilling. Tilly wasn't your typical engineer of the 1940s. She was a trailblazer, a motorcycle racing enthusiast, and a brilliant aeronautical engineer working at the Royal Aircraft Establishment. She was known for her nonsense attitude and her incredible knack for solving complex mechanical problems. When she heard about the Spitfire's engine-cutting issue, she took it on as a personal challenge. While the men were focused on complex redesigns of the entire carburetor system, Tilly approached it from a different angle. She understood that the problem wasn't the engine itself, but the fuel flow under specific conditions. She believed a simple, elegant solution was possible. After weeks of intense work, calculations, and testing, she came up with a device so simple it was almost laughable, yet so effective it was pure genius. It was a small, thimble-shaped metal disc with a hole in the middle. It looked like a simple metal washer. Its official name was the RAE restrictor, but pilots quickly gave it a much more affectionate and slightly cheeky nickname, Miss Schilling's orifice. This tiny piece of metal was designed to be fitted into the carburetor's fuel intake. Its job was to limit the maximum fuel flow, preventing the engine from flooding during a negative G dive. It didn't stop the problem completely, but it gave the pilot a crucial few seconds of full power before the engine began to sputter, which was more than enough time to keep up with the diving Bf-109s. The cost of this little world-changing device, about the same as a few shillings back then, or what we'd call 50 cents today. In early 1941, Tilly and a small team personally flew to RAF bases across the country, working tirelessly to install the restrictors in every Spitfire and Hurricane fighter. The effect was immediate and dramatic. Suddenly, Spitfire pilots were no longer at a disadvantage. They could now follow a Bf-109 into a dive without a second thought. The playing field was leveled. The German pilots, who had grown accustomed to their get-out-of-jail-free dive tactic, were in for a rude awakening. Spitfires were now sticking to them like glue. The psychological boost for RAF pilots was immense. They regained confidence in their machines, knowing they could push their planes to the absolute limit without fear of the engine quitting at the worst possible moment. This tiny 50-cent washer, designed by a woman in a field completely dominated by men, fundamentally changed the dynamics of the air war. It saved countless Spitfires from being shot down and, more importantly, saved the lives of thousands of pilots. It's a powerful reminder that sometimes the biggest problems have the simplest solutions, and that innovation and genius can come from anywhere and anyone. Beatrice Schilling's legacy isn't just cast in metal, it's written in the skies, a testament to her brilliance that helped secure victory. Imagine being a Spitfire pilot in the heat of a dogfight, your life hanging by a thread. You push your plane into a steep dive, trying to shake the German Messerschmitt Bf-109 hot on your tail. But as you go into the negative G maneuver, your engine sputters. It coughs, it dies. The fuel isn't reaching the engine, and you're a sitting duck. This was a terrifyingly common reality for British pilots in the early days of the Battle of Britain. The Spitfire's Rolls-Royce Merlin engine, a masterpiece of engineering, had a critical flaw. Its carburetor, a float-type design, couldn't handle the negative G-forces of a sharp dive. The fuel would slosh away from the intake, starving the engine at the most crucial moment. German pilots, whose Bf-109s used a more advanced fuel injection system, quickly learned to exploit this weakness. They'd simply push their planes into a dive, and the pursuing Spitfires would be left sputtering behind, unable to follow. It was a deadly tactical advantage, and the British Air Ministry was desperate for a solution. The problem seemed complex, requiring a total engine redesign. Something that would take months, if not years' time, they simply didn't have. As the best male engineers at Rolls-Royce and the Royal Aircraft Establishment were scratching their heads, a brilliant yet unassuming woman stepped into the spotlight. Her name was Beatrice Tilly Schilling, an electrical engineer and motorcycle racer working at the Royal Aircraft Establishment in Farnborough. She wasn't an engine specialist, but she was a phenomenal problem solver. While the men were thinking about complex, large-scale solutions, Tilly approached the problem with a fresh perspective and a dose of practical genius. She understood the core issue wasn't the engine itself, but the way fuel was being delivered under specific GI forces. She realized they didn't need a whole new carburetor. They just needed to control the fuel flow. After weeks of intense work and testing, she came up with a solution so simple it was almost laughable. It wasn't a complex new pump or an intricate valve system. It was a tiny thimble-shaped piece of metal with a small hole in the middle. It was, essentially, a precisely engineered metal washer. This little device, which cost about 50 cents to produce, was officially named the RAE restrictor. But to the thousands of pilots whose lives it would save, it was affectionately known as Miss Schilling's orifice, or simply the Tilly orifice. How did it work? It was pure, elegant physics. The washer was fitted into the fuel line leading to the carburetor. When the plane entered a dive and the negative G-forces hit, the restrictor limited the maximum fuel flow, preventing the engine from flooding. At the same time, the small hole in the center allowed just enough fuel to pass through to keep the engine from cutting out. It wasn't a perfect, long-term fix. It could only sustain the engine for a few seconds of negative G flight, but a few seconds was all a pilot needed. It was enough time to follow a Bf-109 into a dive, to stay in the fight, to survive. The simplicity of the device meant it could be manufactured. quickly and installed by ground crews across the country in a matter of hours. In early 1941, Beatrice Schilling herself led a small team, racing from airfield to airfield, personally fitting her invention into every Spitfire and Hurricane they could get their hands on. The effect was immediate and dramatic. Spitfire pilots suddenly found they could stick to the tail of a diving Bf-109 like glue. The German pilot's go-to escape move was gone. The playing field was leveled and arguably tilted in favor of the Royal Air Force. The psychological boost for the British pilots was immense. They no longer had to fear their own machines betraying them at the worst possible moment. They could fly with a newfound confidence, pushing their Spitfires to the absolute limit. This tiny piece of metal, born from the mind of a woman in a field completely dominated by men, gave them the edge they so desperately needed. It is no exaggeration to say that this 50-cent fix saved thousands of lives and played a pivotal role in winning the air war. The story of Beatrice Schilling and her ingenious washer is a powerful reminder that sometimes the most impactful solutions are the simplest ones. It's a testament to the power of looking at a problem from a different angle. While top engineers were focused on overhauling entire systems, Tilly Schilling focused on the root cause and delivered a quick, effective, and life-saving fix. Her contribution was monumental, yet for many years, her story remained largely unknown, overshadowed by the more famous tales of war. But today, we remember her not just as an engineer, but as a hero who, with a small piece of metal, changed the course of aerial combat and helped secure victory. It's a stunning example of how one person's ingenuity can have an impact that echoes through history. Hey everyone, and welcome back to our deep dive into the unsung heroes and incredible innovations of World War II. Today, we're uncovering a story that proves even the smallest component can have a monumental impact. We're talking about how a simple metal washer costing roughly 50 cents helped the legendary Spitfire outmaneuver its fiercest rival, the German Bf-109, and ultimately saved thousands of Allied pilots. It's a tale of brilliant engineering, a determined woman, and a tiny piece of metal that changed the course of the air war. In the heat of World War II, the skies over Europe were a deadly ballet of aerial combat. British Spitfires and German Messerschmitt Bf-109s were locked in a fierce struggle for supremacy. For a time, the German fighters had a crucial advantage. When a Spitfire pilot tried to perform a negative G maneuver, like nosing down into a steep dive, their Rolls-Royce Merlin engine would sputter and die. The carburetor would flood with fuel, starving the engine at the worst possible moment. This gave the Bf-109s, which had fuel-injected engines, a life-or-death edge. They could simply dive away, leaving the Spitfire pilot struggling to restart their engine. The British desperately needed a solution, and it came from a brilliant and unexpected source. Her name was Beatrice Tilly Schilling. She wasn't a frontline pilot or a high-ranking general. She was a motorcycle racing, speed-loving engineer working at the Royal Aircraft Establishment in Farnborough. When word of the Spitfire's critical engine flaw reached her, she immediately dedicated herself to finding a fix. The Air Ministry was in a panic, and top engineers were scratching their heads. They proposed complex, time-consuming solutions that would take the precious Spitfires out of service for weeks. Tilly knew there had to be a simpler, faster way. She understood the physics of the problem intimately during a dive. The negative G-force was sloshing the fuel up to the top of the carburetor's float chamber, flooding the engine's intake. So, what was her genius solution? It wasn't a redesigned engine or a complex new fuel system. It was a simple, elegant, and incredibly effective device. Tilly Schilling designed a small, thimble-shaped metal washer with a precise hole drilled through the middle. Officially, it was called the RAE restrictor. Unofficially, pilots affectionately called it Miss Schilling's orifice, or the Tilly orifice. This tiny piece of metal, costing just a few pence to manufacture, was designed to fit into the Merlin engine's carburetor. Its purpose was brilliant in its simplicity. It restricted the fuel flow just enough during a negative G maneuver to prevent the carburetor from flooding, but not so much that it would starve the engine of fuel during normal flight. It allowed exactly the right amount of fuel through, keeping the engine running smoothly no matter how the pilot threw the plane around. The effect was instantaneous and dramatic. In early 1941, Tilly and her small team flew from one RAF base to another, working tirelessly to fit these restrictors into every Merlin engine they could find. The installation was so simple it could be done in under an hour by ground crews right on the airfield. Suddenly, Spitfire pilots found their planes transformed. They could now follow a Bf-109 into a dive without their engine cutting out. The playing field was leveled. No longer could German pilots escape with a simple push of the stick. This small 50-cent piece of metal had eliminated one of the Spitfire's most significant weaknesses, giving its pilots the confidence to engage the enemy on equal terms. The impact of Tilly Schilling's invention cannot be overstated. It is credited with saving the lives of thousands of Allied pilots. By allowing the Spitfire to match the Bf-109's diving capabilities, it fundamentally changed the dynamics of air combat over Britain and Europe. Pilots could fly more aggressively, secure in the knowledge that their engines wouldn't fail them at a critical moment. It's a powerful reminder that sometimes the most monumental problems are solved not by grand, expensive projects, but by a simple, clever idea from a brilliant mind. Beatrice Tilly Schilling, the woman with a passion for speed and a gift for engineering, created a tiny metal washer that helped win the war in the air. Her story is a testament to the power of ingenuity and the incredible impact one person can have. Thanks for watching, and if you enjoyed this piece of hidden history, make sure to like and subscribe for more.